Students, today I'll show you how to find out the dew point, adiabatic saturation temperature and wet bulb temperature using a psychrometric chart. So let us suppose the initial condition of air is given in terms of dry bulb temperature and absolute humidity of air. Okay, so let us just plot this data on the psychrometric chart. Okay, so we have the y-axis, this is x-axis, this is absolute humidity, this is the temperature line. Now within this you have percentage saturation lines. Let us suppose this is 100% saturation line. Okay, and within the psychrometric chart you have several such lines which are known as adiabatic saturation lines, adiabatic cooling lines. There are many names. Okay, now as I mentioned that the initial dry bulb temperature of air and the absolute humidity values are given. Okay, so suppose this is the dry bulb temperature, this location indicates, and absolute humidity of air are given. So what you have to do, you have to draw a vertical line from the dry bulb temperature, you have to draw a horizontal line from the absolute humidity point, and this is the point of intersection. Let us suppose this is P. Now you're supposed to find out the dew point, and we know that dew point corresponds to a saturated gas which corresponds to 100% saturation. So this point all the way should be extended towards the left, and you will find out the point of intersection with the 100% saturation line. Come towards the temperature axis or the abscissa, you will have the dew point value. Okay, very simple. And then after that comes the point where you need to find out the adiabatic saturation temperature. To find out, you have to trace a path corresponding to adiabatic saturation lines that are already given in the psychrometric chart. Okay, so what do you have to do? Corresponding to the given adiabatic saturation lines within the psychrometric chart, you draw a line via linear interpolation, but smarter way of doing it would be drawing a parallel line corresponding to the adjacent lines. Okay, so this is the line. Suppose another adiabatic saturation line is this one. So from this point you follow a path. Okay, and adiabatic saturation also corresponds to 100% saturation. So this adiabatic saturation line will intersect the 100% saturation line at point Q, and then you come towards the x-axis, and this is going to be your adiabatic saturation temperature, which is below the dew point. Fine. Now comes how to find out the wet bulb temperature. Now to understand that, we have to first understand the mathematical equation. The mathematical equation for adiabatic saturation temperature lines are y prime minus yas prime divided by T minus TAS is equal to minus CS over lambda S. Okay, so y prime stands for absolute humidity, yas prime stands for humidity corresponding to adiabatic saturation, T stands for the dry bulb temperature, TAS stands for the adiabatic saturation temperature, CS stands for the humid heat, and lambda S stands for the latent heat of vaporization of water, and we are discussing water vapor air system here. Okay, now the mathematical expression for humidities for water vapor air system is 1.005 plus 1.88 y prime divided by lambda S. Now since absolute humidity values are very small, the numerator can be roughly approximated to be equal to 1.005, roughly in that range. The value of lambda S is around 2500 kilojoule per kg. So this is basically the right hand side of the equation. Okay, so let it be equation 1. Now let's see what is the mathematical expression for wet bulb temperature. Okay, so it is y prime minus yw prime T minus tw is equal to minus hg over mb ky divided by lambda w. Okay, so y prime stands for absolute humidity, yw prime stands for humidity corresponds to wet bulb temperature, T stands for the dry bulb temperature, tw stands for the wet bulb temperature. And on the right hand side in the numerator you have a ratio called hg divided by mbky. Now this ratio on the right hand side is known as psychrometric ratio. Okay, and for water vapor air system, the value of psychrometric ratio ranges from 0.96 to around 1.005. Okay, so right hand side of this wet bulb line equation would be approximately 0.96 to 1.005 divided by lambda w, which happens to be the latent heat of vaporization of water, which is around 2500 kilojoule per kg. So let it be equation 2, and if you just compare equation 1 and 2, it's quite evident that the right hand sides are equal, and for that reason, for that logic, for water vapor air system, it is given that the adiabatic saturation lines and the wet bulb temperature lines are same, and this is true and only true for water vapor air system and not for suppose organic vapor in air or any other cases. Okay, because in those cases the value of psychrometric ratio won't range between 0.96 to 1.005, and for that reason within the psychrometric chart we assume the adiabatic saturation lines are similar to that of wet bulb temperature lines, and for the same reason the value of wet bulb temperature will be same as that of adiabatic saturation temperature. Okay, so in this way we can easily find out the value of dew point, the adiabatic saturation temperature and wet bulb temperature quite easily. Thank you very much.